Curve sketching. Now with curve sketching, last time we went through how to tell what type of points you have. This is showing you how you can sketch a full graph, including the turning points. So we've seen this bit before at the start, where you find the x and y intercepts. I don't need to go through that again, I'm hoping. Do I? No? For y-intercepts, you sub in x equals to 0. For x-intercepts, you sub in y equals to 0. And then, this is the separate section here that's new. Calculate the x-coordinates of the stationary points. Identify those stationary points. Then you calculate the coordinates of the endpoints. Then identify any other features. That's the new bit. Any questions with it? Alright. So you sketch our function, locate any intercepts with the coordinate axes and any stationary points, and justify the nature. So now, to sketch that, we firstly need to find our x and y intercepts. So which one do you want to find first? Y-intercept, because you don't have to do anything, sounds good. What's our y-intercept for that, without doing any working out? Yep. It's always that one. X-intercepts, how do we find that? Sub in y equals to 0. From here on, I would suggest you use a calculator, or if you need to, you can work it out by hand. What would go in? Maybe a 2? 8 minus 8, 2. Yes, 2 would go in perfectly. So let's test it out. If we test plus 2, I think. Yep. So if you try it out with 2, that's a half times 8 minus 3 times 4 plus 6 times 2 minus 8. 6 times 2 is 12, 3 times 4 is a 12, so they cancel out. Then minus 8. Damn it, so close. Okay, maybe we'll just put it in the calculator. Alright, apparently x equals to 4 is the only one, so I'm just going to trust you guys. X equals to 4, therefore we have 4, 0. Alright, so we found our x and y intercepts. Now, we then need to differentiate if you follow the order, and then find our x coordinates. So if I differentiate, that's a y, so we use dy dx. Dy dx is equal to, you take the power down, remember, so that's 3x squared over 2 minus 6x plus 6. Then what do we do from here if they're stationary points? What must they be equal to? 0. So make it equal to 0. Once they're equal to 0, then you go through and solve it. If you're a little bit stuck, I would suggest you times 2 and then divide it by 3 for both sides first, just to make it easier. So then you get 3x squared minus 12x plus 12 equals to 0. I might not have enough space to do the graph. Then divide all 3 of these by 3. So x squared minus 4x plus 4 equals to 0. Then that's nice and easy, because what does that give you if you factorize it? Yep. So x is equal to 2. Then, once we've found the x coordinate, we need to locate, follow this in order, locate any intercepts with the coordinate. So that means find it first. So we'll swap this back into y. And then I found this before, which is 4, wasn't it? Anyone remember? Yeah, I think it's negative 4. So 2, negative 4. Then we need to find its nature. I'm just following the sentence, by the way. Locate any intercepts with the coordinate axes and any stationary points. So we found the coordinates, which is part of the stationary points. Then it says justified in nature. Alright, now I'm going to use a sign diagram to justify this nature. You can use the other way if you like. It says it's x minus 2 squared, which I know you can graph it very, very easily. So you should have that. No, you don't. You should have. I can't graph it. You should have that. Given that it's positive, what kind of nature is this? If it's going positive, back to positive. Plus 0 plus. See here? Plus 0, then a plus. It goes up, then flat, then up. What is that? It's a point of inflection. Then, okay, so once you've done all of that, you just simply put them all in. So, whoop, we don't want green. Use a ruler, obviously. So negative 8, then at 4, then 2, negative 4. Now, this is positive right here, so this is going to go up, then it's going to go flat, then back up. Try it again. That looks better. Then label your points and you're done. Any questions? Fairly straightforward. You simply have to follow the order. You find your x and y intercepts, find your stationary points, then you just put them all in and graph it. Okay? Nothing too bad? Alright. This is kind of confusing on the statements if you follow the statements. You can read it if you like. I'm just going to tell you what the differences are, because it's a lot easier telling you what the differences are rather than reading it. That and that are your highest and lowest points, right? Because they're your graph's absolute highest and lowest points, you will call those global maximums or global minimums. Yeah, fairly straightforward. If you want to look at, yeah, that's right, green. If you want to look at the turning points, we call them maximums and minimums, but they're only around that small region, correct? So we will call these local maximums and minimums. Does that make sense? Those four things match the statements on the left, but you can tell it's really confusing to read it, but graphically it's really easy to visualize. Okay? So if you ever get stuck and it's asking what a local maximum, what a local minimum, global maximum, global minimum are, that's what they are. Now, can I get you guys to grab your CAS out for a second? Because I'm just going to show you something with that. I have a picture of Ilios in the background. Or Chantel. Okay, where Ilios it is. One of them. How about we have all of you? Okay, what I need you guys to do is I need you guys to go into the graph table, so graph and table here. Then I would like you to put that function that I've just put in there onto your calculator. So x cubed minus 2x squared plus x minus 3. But I need you guys to set a domain. There's a reason for that. Make sure you put a domain in. Once you put that domain in, I would like you guys to graph it. Then we'll just adjust the viewing window once you're done with that. Is that 2.5? Yep, 2.5. So -1 to x to 2.5. Now, it's just some random one that I made up. Don't stress, I'm not doing this for anything else other than showing you how this works. Now, if this graph is not quite right for your viewing window and you would like to change it, the best way to change it is to go on settings and then viewing window. But before you actually go onto the viewing window, have a look at the graph first. We set the domain going from -1 to 2.5. Always set it very slightly bigger than what it says. That way you will have the whole thing in the window. And then if you look at the height, that goes to about 3. So maybe we'll set it at 4. And then the bottom here, that's -10, so -9. So maybe set it at -8. So let's go ahead and put that in the viewing window. So -2, and I set the maximum as 2.5, so let's do 3.5. That's not a 5. Now this scale one, all it does is it changes the scale here. You can leave that if you like. If you have really big numbers, I would suggest you not have 1s, because otherwise there's way too many lines on the bottom and it doesn't look very nice. Entirely up to you. This dot one just changes the size of these scales, or the size of a line. So again, you can just leave that. And then y min, we set -8. Maximum, I think I set 4. Then once you're done with that, press OK. There are some angle ones, we'll worry about that later. Ta-da! Looks quite nice, doesn't it? Now, the reason why I'm showing you this is so that you can find the local minimums and local maximums. They are actually separate on your calculator. So if you go on Analysis, Gsolve, you have 4 different ones. You have min, max, fmin, and fmax. The reason why we set a domain is so that we can actually find the maximums and minimums of the actual function. If it says fmin, that's the global minimum. So see that? It points at the lowest point of the whole graph. That's what fmin is for. So fmax will be a similar thing. You'll find the highest point, the absolute highest point of a graph. Then you have minimums and maximums. I picked one with 2 turning points. That way you can check it. So there's the minimum. Now when it says minimum, it'll only look for the local minimums. So if you needed to switch in between local minimums, press your left and right buttons. Fairly straightforward. Then there's also a maximum that you can find. There you go.